All right, Amira, are you there?
Yeah, I'm good.
All right, let's move on. That is the last exponential equation for this. Actually, we are going to do more exercises, a bit different. Okay, so that is some basic concepts about indices and the surds. So find the value of x for 2 cubed times 16 equals to x. Now we know the idea. We have to simplify the left-hand side. We have to simplify the right-hand side and bring into the same base. And after that, drop the bases so that we can have another simpler algebra equation and solve this. So here we have 2 cubed times 16 is 2 to the power of 4. On the right-hand side, we have 2 to the power of x. So here we have 2 to the power of x equals, on the right-hand side, we can simplify this 2 to the power of 7, right? So bases are the same. So that means also exponents must be equal to each other for these two things to be equal to each other. So that is x is along here. That gives us the solution. So the solution of the given exponential equation is 7. That is very basic fundamental ideas about exponential equation. Now we are going to talk about another concepts. Standard form of a number. I think maybe you studied this in grade 7, I guess. Do you remember? When did you study this?
Yeah, I started it in year 8, but I think we were meant to do it in year 7.
Oh, do you remember what it's about?
Yeah.
And
So you have a
why?
number, and then like the number can't be more than I think the number can't be more than 9 or something, but you times it with 10 to the power of something else.
Yeah, okay. So actually, also mathematics, the concepts, when mathematicians actually introduce new concepts, and there's a reason, there's a purpose, right? And also a standard form, when mathematicians developed mathematics, and they had to deal with very big numbers. For example, very big numbers or very small numbers. If you just talk about daily life situations, small numbers is fine. You're buying something, counting money, measuring the distance between two cities. And how about if we measure the weight of the sun? Okay, how much heat is produced by the sun in a day, for example? What is the distance between the earth and the moon, for example? Right? What is the age of the earth, for example? And how many human cells are there in our body, and this kind of stuff, for example. And just writing them in usual notation, it will be very huge. That's why to write this in a more actual compact form, mathematicians introduce this concept. That is the standard form of a number, or scientific uh, form of a number. Just one example, speed of light. What is it? It is 3 times 100 million meter per second. Now see here, writing in this form, it requires us to write a lot of digits. So if I just write this in this form using that exponent or index, right, it's just equal to 3 times 10 to the power 8. And also dealing with this number is much easier. I can just see this in a very compact form. Another example, for example, wavelength of violet light. There's a kind of light that is wavelength. It just moves in a wave shape, okay? Its length is 3.8 times 0 times 0.0000 something here. So actually writing this one is not so practical. That's why actually after writing, having a lot of difficulties, then they felt a kind of need to use different notation, simpler, compact, and easy to use. So that's why actually they introduced this standard form. So we can just write this as 3.8 times 10 to the power minus 5. So now what is then standard form of a number? When you just say standard form of a number, every part of the world, anybody who's dealing with this number, they should understand the same thing. So actually they define the standard form of a number in this way. Standard form of a number is this form, that is a times 10 to the power n, where this a is between 1 and 10. That is not inclusive, and from the left is inclusive. That is greater than or equal to 1 and less than 10, and n is an integer. And we know what we mean by integer. That is -5, -6, maybe 0, 1, 2, 3. Okay? So in daily life, actually, every day we are using these things these days, right? Like kilo, for example. That kilo means, what is it? 1,000. Kilogram means 1,000 grams. Mega, megamoles, actually it means something different in math. Mega means million. 2 10 to the power 6 million. Giga, gigahertz, gigabytes, whatever it is. We are using this a lot these days, right? Giga means 10 to the power 9. We can continue this, tera and blah, 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 but that much is enough just to get some idea. How about tera? Now, these days, we just use terabyte, right? If you buy a laptop or if you buy a hard disk, something, now it's like 1 tera, 2 tera. Maybe 5 years ago, we were not using, we were using only giga. Now we are using tera. Maybe after 5 years, this will not be enough. We need to use another unit here. That is 10 to the power 15. Right, it's just increasing by 3, 10 to the power 3, 10 to the power of 6, 10 to the power of 9, 10 to the power 12. Next one is 10 to the power 15. Next one is 10 to the power 18. That's called exa, some Greek names. And how about for small numbers? We have milli, that is milligram, 1,000ths, right? So that is 10 to the power minus 3. Macro, that is mu, that's in Latin, Greek letter, 10 to the power minus 6. Nano, that is 10 to the power 9. Pico, 10 to the power negative 12. And these numbers are used in a lot of scientific calculations. So we'll see a few examples related to standard form. For example, the approximate mass of the moon is 7 times 10 to the power of 19 tons. Exatons means, exa means 10 to the power 18. Huh? Okay. So exatons, while the mass of the Earth is approximately 6 times 10 to the power 24 tons. Calculate the number of times that the Earth is as heavy as the moon, giving your answer correct to the nearest 1,000. Actually, we'll see this kind of questions in GCSE papers. Okay, they don't just ask simple questions, they may ask, but usually they ask this real life question. So here, that is the mass of the moon in tons, right? That is the mass of the Earth in tons. It says calculate the number of times that the Earth is as heavy as the moon. So that means that here we have Earth, that's the mass of the Earth. How many times bigger? We don't know. Let's say it is n times bigger. So n times the moon gives us the weight of the Earth. So the question is, what is this n? Right? Calculate the number of times that the Earth is as heavy as the moon. So give me an answer correct to the nearest 1,000. Good. That means that to find this m, so we need to just divide both sides by m. So we get this expression, E over m. Now what is E? E equals, here it is Earth, 6 times 10 to the power 24 over, how about moon? That is 7 times 10 to the power 19. And if you simplify this, what we have here, 6 over 7 times 10 to the power 24 minus 19, it is 5, right? And now we can just write this in standard form. It says, giving your answer correct to the nearest 1,000. So that is 6 over 7. 6 over 7, 6 over 7, and times 10 to the power 5, 10 to the power 5. So when you just evaluate this, we get 8, 5. This thing is 8, 5, 714, 714.28, and 5, and blah, blah. And the question says that giving your answer correct to the nearest 1,000. That means that we are counting everything in thousands, right? So actually here, we need to just round off this part. So the answer is now, what is it? That is 86000 to the nearest 1,000. So that means that the Earth is 86,000 times more, actually heavier than the, what is it? The moon. Okay?
Mm-hmm.
Okay. So maybe Amira, you will do this question. The table below shows the approximate population of the world in the past centuries. That is in 1549, 1649, 1749, and 1849. So during this year, the population of the world was this, 4.20 times 10 to the power 8. After 100 years, there's some increase here, 5.45 times 10 to the power 8. After 100 years again, that is 7.28. Okay. After 100 years, it is 1.17 times 10 to the power 9. Okay. Question A. Find the increase in population from 1549 to 1649. How do you find that? We should just subtract, right? To find the increase, we need to subtract. So we need to subtract this number from this number because it says find the increase, right? How many people increased during this 100 years? So the question A, the answer will be the increase, that is 5.45 times 10 to the power 8 minus 4.20 times 10 to the power 8. And how do you evaluate this? It is 10 to the power 8 is a common factor. And 5.45 minus 4.20, what is it? It is 1.25, right? So that is 1.25 times 10 to the power 8. And also you can leave our answer in standard form. So that is in standard form. This number is between 1 and 10, less than 10. And here we have 10 to the power something. That something is integer. So actually during this 100 years, the population of the world increased by this number. Or if you just write exactly what is it, that is 125 million. Okay, so it increased by 125 million during this, what is it, 16th and 17th century. Okay, question B. The number of times that the population for 1849, here we have 1849, is as large as that in 1649. Okay, here we have 1649 and the 1849. So actually to do this, we need to, again, what is it? That means that here it is more, right? Number of times. So n times this population is equal to, n times this population is equal to this thing, right? So to find this n, right, maybe we can do this here. Question B, what is the population in 1849? 1.17. That is n equals 1.17 times 10 to the power 9 over, and how about population in 1649, right? 5.45. So 5.45 times 10 to the power 8. So that is equal to, so 8 10 to the power 9 over 10 to the power 8, that is 11.7 over 5.45, which is equal to 11.7 is divided by 5.45. That's equal to, okay, the number of times, that's, okay. So that's equal to, approximately equal to 2.14 or 67, something. So that's actually the answer is then approximately twice, right? 2 times the number of populations 1416, or the number of population of the world during these 200 years increased twice as much as in 1649. But if they ask this exact answer, then we should just simplify our fraction, this thing, let's just leave it like that. But this is approximately. So how about question C? The number of times that the population of China is as large as that of the world population of 1749. Okay, it says is, all right. Given that the population of China in year 2000 is approximately 1.23 billion. What's the question? Find the number of times.
You need to do the same thing as you did in B, but with the population of China compared to the population of the whole world?
In 1849?
No, in 1749.
1749. Okay. So we should just divide this number, right? 1.3 billion. Billion means 10 to the
Yeah.
power 9 by this number, right? And just simplify and get the answer. Okay. That is one question about standard form. Another example, we have maybe, how many examples? Okay, 3, 4 examples. Also, it's a similar example. It's just the use of standard form in problems or application. The mass of a hydrogen atom is approximately 1.66 times 10 to the power negative 27 kg. Very tiny thing. Of course, we cannot see it. How many atoms are there in 1 gram of hydrogen? Okay, how do you solve this question?
You.
So here we say a hydrogen atom, right? Just one piece, that's atom, something like this, whatever it is. The mass, let's say, mass of this thing is 1.66 times 10 to the power minus 27. And here we have gram. Also, we need to convert this into grams. So here we have times 10 to the power of 3 grams. Okay. So the question is, how many atoms are there in 1 gram of hydrogen? So maybe here we have a kind of bag, but inside we have some hydrogen. All right. The mass of this one is capital M. Okay. That's equal to 1 gram. That's equal to 1 gram. Right. So here, how many hydrogen atoms we have? In such things, how many we have? Let's say it is N times M. Right. At the time, a similar question. What is N? That is equal to 1 over M, right? Because the mass of the whole thing is 1 gram. So actually inside how many atoms we have, we don't know. But we don't know, we know the individual mass, the mass of one hydrogen atom. And here we are assuming there are N such atoms inside this container. So just for using this equation, we can find N. N equals 1 over M. We have here the unit of measurement is gram. On the right hand side also it is gram, right? They cancel out each other. So what do we have here then? Here we have 1 over, we know what is M, that's equal to this thing. That's equal to 1.66 times 10 to the power negative 27 plus 3 negative 24 here, which is equal to 10 to the power negative 4 over 1.66. Right? So how many atoms? We have this many atoms. We can simplify this. Now, if you just write this in standard form, how can I do that? We can just write it as 10 over 1.66 times 10 to the power 23, right? And 10 over 1.66, that's equal to 6.02, or that's equal to 6.024 to 4 times 10 to the power 23. So we have, of course, actually in the exam, they mention everything exactly. For example, leave your answer correct to 3 significant figures or 4 significant figures, or write your answer in standard form and leave this A in a certain given precision. But here nothing is said. Okay, we are just leaving our answer like this. Okay, now you got the idea, I think. If you're given this kind of question and using the standard form and solving it. So now we have 2 examples, 2 or 3 examples. And with this, I'm going to finish this first part of this chapter. And maybe in the second part, I'm going to involve you more. Maybe we'll just solve the problems and I'll write it down. Okay. So another example is from a review example. As you know, at the end of each chapter, we have 1 or 2 review examples. And after that, we have review questions. Also, I send you all these materials from chapter 1 to chapter 4. Anyway, you will, when you have a look, you will see. So here, solve the equation. It's a little bit different, and I think I am sure you can solve this problem. First, we have to simplify the left-hand side and also right-hand side. Now, from here, we can see that we try to write everything in the power of, not the base of 2, right? So the 16, we can write it as 2 to the power of 4x is divided by, here we have 2 to the power 2x times 3, that is 6x. And how about 0.25? That's equal to 25 over 100, which is equal to 1 over 4, which is equal to 2 to the power of negative 2. So here we have 2 to the power of negative 2. Now, if you simplify this, bases are the same. 4x minus 6x, 2 to the power minus 2x equals 2 to the power of negative 2. Right? So negative 2x equals negative 2. From here, x equals 1. All the things, what are this? Actually, we are just using that equivalence, preserving operations. That's so how we call in math. Okay. That is just adding something, the same thing to both sides, or multiplying, or dividing, or taking a root of something, raising to the same power. Okay, anyway, what we got here is, using some algebraic manipulation, we got equivalent equation, but very simple form. Okay, so that means that whatever satisfies this equation also satisfies this equation. Actually, we call this the solution of the equation. Anyway, that's one example for exponential equation. Another one is about simplifying indices. So here we have two fractions is divided. First, we have to clear the brackets, and after that, change this division into multiplication. Then after that, simplify. So in the first step, if you remove the brackets, right, I can just write it as x to the power 5, y to the power minus 4, over x to the power of minus 3, y squared, z to the power 5. And just here, instead of minus, now we have plus, because upside down, we have just changed this upside down. And here, times, and also we have to write this upside down. Here we have nothing, no problem here. So here we have x to the power minus 4, y squared, and z cubed over x squared, y to the power of minus 6, and if we have to the power 4. And because we change this division into multiplication, that's why we have to write this fraction upside down. Now, if you just remove the brackets, at the same time, we have to simplify first. X to the power 5 minus x to the power, and divided x to the power of minus 3. What we have here, we have x to the power of 8 times, how about here we have y to the power minus 4 minus 2, here we have minus 6. And how about here, z to the power of minus 5, here we have 4 times. How about here, minus 4 minus 2, here we have x to the power of minus 6 times y to the power of 2 minus minus 6, that's 8, times z to the power of 3 minus minus 6, that is 9. No? We have nothing, right? Only 3. It is 3. So here we have negative 4. It's 4 only. Here we have 4. Okay. All right, sorry. Here, our exponent here is 3. Here it is 4. We have just simplified the fractions. Now, if you clear the brackets, what do we get here? 8 times 3, 24. And y to the power minus 6 times 3, minus 18. And z to the power minus 15 times. How about here? Minus 6 times 4, x to the power of minus 24. Y to the power of 32 times z to the power of 12. So now we can just combine the like terms, not like terms, actually similar the same basis. Here we have x to the power 24, x to the power negative 24. They are gone, is equal to just 1. And y to the power negative 18 times y to the power 32, that is y to the power negative 18 plus 32, that is 14. And z negative 15 plus 12, that is minus 3. So we have just simplified the given exponential expression or algebraic fractions. The last example, can you read it, Amira? Let me have rest while you read this question.
Okay. The British pop group Beatles sold a total of 1.1 billion records worldwide. If each record was priced at $24.9, how much money was received? If the money were used to buy each of the following, how many of each of the following can be bought? A 1,600 litre car, which costs $58,600 each. B, an MP3 player, which costs $108 each. C, a meal for a family, which costs $4.5 each.
Okay. So the British pop group Beatles sold a total of 1.1 billion. That means that's 1.1 times 10 to the power 9, right? Records worldwide. Okay. If each was priced at 24.90, how much money was received? First, we have to answer this question. So that part is, we can just write here, that's, I don't know, the first step. How much money was received? The total money, let's say $T were received, the total. So the $T and how many? 1.1 times 10 to the power of 9 times each one is sold at 24.99, right? So that is equal to, again, we have to write this in standard form, that is 1.1 times 24.99, that's equal to 27.489 times 10 to the power 9. But now it's not in standard form, so immediately we can write this in standard form because this number should be less than 10 and greater than 1, or greater than or equal to 1. So if I just shift this decimal point 1 to the left, and here we have 2.7489 times 10 to the power 10. Okay, actually they received that much amount from the people by selling their records. All right, so that is the main question here. And after that, using this result, we're going to answer these questions. In question A, a 1,600 liter car, which costs 58,600, right? How many such cars can we buy for this money? To do this one, just we need to divide this number by this, right?
Mm-hmm.
So this one, let's say it is, we can buy N cars. And an MP3 player, which costs this much, let's say we can get M such MP3 players. A meal for a family, which costs $4.50. So let's say it is K. We can buy for K people lunch, which is $4.50, right? From here, what is M? Let me just answer N. Here, that N is 2.7489 times 10 to the power 10 over 58 times, or, okay, 58 times, not 58, 5.86 times 10 to the power 2, 3, 4. So here we have 4, right? Now we can evaluate and write the answer. In a similar way, you can just divide this number by 168 and get the value of M, and divide this number by 4.50 and get the result here. And here we can just use a calculator to evaluate this.
Mm-hmm.
Okay. Good. All right. Amira, I'm thinking to give you one exam paper, maybe next week. will you have time to do this? Because I just want to see how actually you are solving the problems, how you think, and in this way, I will see your your mathematical knowledge. Okay, because now you understand the problems you studied before, and once again you are just revising this. Okay, and also you know that in the exams the challenge is not only your knowledge, right? You may have knowledge about certain topics, but also you need to have speed, right? And also time is one of the biggest challenge, because when actually solving problems, if I ask you to solve these problems in 5 minutes, and you will have a kind of pressure, right? That is more challenging. But if you just give an assignment, okay, time is not limited. Anytime you can try, and even if it takes hours, you can just try this. But in the exam, it is very different. And that's why if I give you some questions, and I will give you like 75 minutes, and maybe I'll give you around 10 or 15 questions, if you just write down everything in the paper, okay, and take scan it and send it to me. So I would like to see this. And when can you take this exam? Let me know. Next week, it may be Wednesday or Thursday, and any time is fine. But just I want to see your work on all the questions. I'm going to prepare exam from chapter 1 and chapter 2. Okay, it's about quadratic equations, and it's indices, surds, and standard form. You think about this now. You don't have to answer now. You just tell me on Sunday. Okay, Mr. Qasim, okay, this day I can do this. Let me see your work, all right, how you're solving problems. And after that, you'll continue. Okay, that is what you have to do, and tell me on Sunday. And next week, you will have a kind of test. Amira, also the chapter 1, 2, 3, 4, all actually materials I have already shared with you in WhatsApp. And if possible, you have to download and keep it in a folder. You just write math class and keep it like in chapter 1 and chapter 2. And if you're just writing or doing some assignments, keep it on the paper and scan it, and also your file, save it there. And when you're done, actually when you finish chapter 1, please send it to me. How many can you do? Okay, I just want to see your work. And after you finish chapter 1, do some questions from chapter 2. Okay?
Okay.
That's good. So Amir, now let's start a few things. We will continue, and after that, I will finish the class. That is the first part about indices, surds, and standard form. Now we will do a few more questions, a little bit challenging and not difficult for you, I think, but it's a little bit higher level. It's about indices and surds, and that is enough for this chapter. Amir, do you have any GCSE math book in your hand?
No, everything's online.
So
We have to
online,
log
are you
in.
using any kind of material? How about resource?
Pardon?
But the school does not provide any e-book?
No. They just have lessons, and then we're meant to just do the homework and then submit it online.
Okay. But your school is not over yet, right?
Yeah, it's not.
Still, you have school now?
Yeah.
Okay, good. All right. It's all about indices. We have talked about everything, but just the questions are a bit different, okay? So we'll just see a few of them. Let's start with this question. I wish I could write your writing, Amira. Still, you couldn't actually connect your, you cannot use your surface here?
No.
Interesting. Now, are you using your surface now?
Yeah.
You have a pen, right?
Mm-hmm.
Okay, let me just try something here. If I allow you to share screen, or if I do so, then I cannot share my screen. Interesting. Okay. Let me ask our IT guys, how can we do that? Yeah, because when I teach my class, to my students, they can write a notes. Actually, they don't use Surface, they use just iPad. But when they write, I can see. And I wonder why you cannot do that.
Actually,
Okay, I will.
let me search it up.
Okay, just try and maybe search on the internet how can I do that, because with other students, I just teach in a similar way using Zoom, and I share my screen like this, and they can write the notes, and they
Oh, I
with
think I figured it
iPad.
out.
Okay.
Wait, let me try. Yeah.
Yeah, you can do that. Okay, Amira, now here, can you solve question C? Let me just watch you.
Which one?
C.
C.
Yeah, can you see now
Okay.
here, we are example 2, right? We have 3 questions.
Yeah.
Can you solve this?
Okay.
I'll give you 3 minutes. Write everything here.
Okay.
Okay, start.
The pen is a bit strange.
Maybe you should change your pen. Just right click and change the pen. Okay, that's better, I think. Good. I mean, there actually, it's not plus, the 6 is in the exponent, right?
Yeah. So the 3 is like bigger. Sorry, it's not clear.
Okay.
And this is also a times.
Mm-hmm.
Or is it just 8?
right, that's 3 to the power 4x. That is, okay, 8. And 4x, that's 9. Eight. Now here, why did you write 6 here? This one.
That's from here.
No, it's in the numerator, right? It's here.
Yeah.
Ah, from
Wait.
here, okay. Does this 2 become 6? It should be 2, right? Because here we have 3 to the power of 4x plus 2, 4x plus 2, 4x plus 2. Right? So it should be 8 times 3 to the power 3x plus 2. So here we have, is it 3? 4x? No, it is 4, right? It's 4, so it should be 4. Okay, this should be 4. So Amira, are you comfortable with writing on your screen, or because your writing is?
Yeah, I think so. I just need to like organize it better.
Okay. So here we have 3 to the power, all right, x, 3x, 3 to the power 4x, 3 to the power negative 4, and plus 6. So here we have 3 squared times 3 to the power 4x. Is it like this? Okay, you just cancel out these two things, right? That is 8. Okay, that's correct. Okay, good. That's good. All right. Interesting. Your writing now appears on every slide.
Yeah. Should I clear it?
Yeah. So that's different. Okay, good. Very good, Amira. Then I think you should just have a look and answer the questions, not all the questions. This kind of questions, out of 10 questions, practice maybe 4 and 5. Okay, in this way you'll just revise it. Okay. And let's see. So that much is enough, Amira. Next time, maybe we'll talk about chapter 3. Okay. It's about linear inequalities, and chapter 4, I just sent you coordinate geometry. Let's continue how it goes, and after maybe 3 or 4 weeks, we will discuss and how is it going, if you want any change in our studying methods, okay? And accordingly, we'll make our plan and continue with this. Amir, thank you very much. All right, enjoy your day. See you on Sunday, okay?
Okay, thank you.
Okay.
Bye.
Bye-bye. Bye-bye.